In this arthrocytology case, we have a patient who's developing a double ring pattern, more so in the right eye, but some in the left as well. And the lenses are also bound quite tightly in the mornings. Here are the lenses that the patient's wearing, and we can see that we're trying to move a fairly high volume of tissue because it's a slightly higher refractive error. And we get this double ring because we have a gradient force going this way and a gradient force going this way, but it's not enough to meet in the middle. So we're getting transition of tissue, but it doesn't meet in the middle. And the way to correct that is to reduce how much volume of tissue we have to move. So the way to do that is to reduce the OZ size, and then at the same time we're going to loosen the lens in the periphery. That will give us a little bit less gradient peripherally and a little bit more centrally. So at a 1.66, which I think is probably okay for a minus 550 cornea, I'm going to drop this one down about a little more than half a millimeter. And then do the same thing to the IC. We do have to adjust the topo demand. We're a little bit high now. So now we're pretty similar to where we were before. And looking at the graph, we can see we're moving a lot less tissue now. I would recommend spinning around and trying to make this as uniform as possible. We're in freeform mode. Incidentally, I think with this cornea, we could probably do GSIM or even RSIM. It's very symmetrical. But since we're in freeform already, I'm going to leave it in that mode. Okay, so we're pretty uniform. We'll go back to 100%, and we're going to lift the periphery a little bit. It'll look like we're going to zero clearance centrally. Probably won't be exactly zero. This is just a software estimation of the tear film thickness. So with a little bit less seal off peripherally, we'll get the lens to not bind down as heavily and hopefully be a little bit easier to remove in the morning. I would go ahead and make the same changes to the left eye. An additional thing I changed on the left eye is to flip the center and edge thicknesses. We want a thicker edge to reduce lens binding, so I would make this one the 24 and then make the center thickness a little bit thinner. So I usually use a 22. I think you were at an 18. Maybe we can go somewhere around the middle. But a thicker edge is a little bit less likely to bind in the periphery. So reduce the OZ and IC, adjust the power, and then loosen the periphery a little bit. That should get the lens to not seal off quite as tightly. The power is a little bit lower on this side, and if you're still getting a zero post-wear refraction, then that's fine. I assume it's a little bit higher on the right because there was a little bit of undercorrection. So I think that's fine. I would go with this type of strategy for redesign and should get your patient doing a little bit better. So hopefully this is helpful. Best of luck and thanks for watching.